So the next thing I want to cover is Unicode. So Unicode is an international standard for encoding, representing, and processing text. So what it does is it enables you to represent pretty much any character from any language in a standardized form, and to read and write these characters. All Swift types of their string and characters are fully Unicode compliant. So what I really wanted to do is kind of show you some escape characters. If you notice when I did print out some things, you notice that there's this \n, and what that is backslash a new line. We have \t, which is for tab, \r, which is carriage return. I believe this is null. Then we have our \\. So say if you wanted to, if we did like a print statement here. So when we do like say a print statement, and usually when we do \, usually we add some code, like we want to print out name, for example. As you see, we have Bob n \. So what that means is that it's a new line. So if we print out again, do another print statement, but this time it's like greeting. What it should do is greeting should appear on the line after it, and it does. So we have that. Just want to show you \tab. So actually you have to do it before here, so \t. There should be a tab now in between, or tab spacing between Bob and the first quote. If we wanted to have, like, say, a \, inside of our print statement here, or even in our strings, we do \, so that it will print out down here, because these are reserved characters, so Swift looks at these as part of its code. Same thing with double quotes. We notice we use double quotes in defining our strings and also in print statements. So say if you want to do a double quote instead, so let's say Bob is we do \, sort of \, awesome. Now we can see our double quotes will appear in our print statement instead of being considered part of the actual code for the print statement. And same thing with single quotes. So if you want to use a single quote instead, you just use \, and then before the actual single quote. Another thing I really wanted to bring up is a list of Unicode characters. As I was studying this, I was looking for a particular Unicode character, and I really didn't know where to turn, so I Googled it. So definitely Google, but the best one I found so far is from Wikipedia. They have every possible Unicode you could want at this point. If you find something else, let me know if you find something better, but I think this was pretty extensive. So what I really wanted to show you, I'm going to show you an example of how I used this actually this week for an app project I'm working on. But basically, you can create any character from Unicode. So if we go back to our Unicode here for exclamation mark, instead of doing the actual sign, what we can do is we can actually use this code here. If we copy that, we can actually create, let exclamation point, we say that this is a character, we can actually create it using its Unicode. And so how we do that, we do our double quotes, \u, curly brace, and then the number, and then end with a curly brace, and what should output is our Unicode. Oh, exclamation point, I'll just do Unicode. That's my error, using the same variable. And you see here, it's exactly what outputs. So we can easily use Unicode to represent characters. Here's another example that's actually from the Swift documentation, but I thought it was pretty cool because you can actually combine Unicodes to create like foreign characters. In this example, we have E acute. So we have E, then if we add the Unicode for the acute sign, it actually combines it. So for my example, because I think it's great to have an example of, sometimes you don't know when you're going to use this, sometimes you do. Using the special escape characters, you can use that at any time, but the example I wanted to show you is my calculator. So I'm building this calculator, and right now I have this square by button as square with the caret and 2. Now, that's not too pretty. I rather have a superscript 2 rather than the caret 2. So one thing I can do is I can actually change this label at runtime because I would like to see square 2 when I'm working on the back end. So what I can do is I'm actually going to drag this over here and create an outlet. I'm going to name square button. I'm going to connect it. So now I have my square button. Another thing I'm going to do is when this square button appears when my actual calculator app is loaded, I want it to change the label. So the way I do that is I'm going to change or make my updates in view did load, and then I'm going to have my code here to change the title of this button. So I'm going to do square button, and then I'm going to do set title, which is exactly what I want. And when this title is set, what I want it to do is I want it to be 2 superscript S, or sorry, 2 superscript, sorry, X superscript 2. Alright, so if I go into my Unicode here, what I can do is I can actually look for X. So let's find the letter X. Let's see here. Alright, that's the capital letter X. I want the small one. So here's my small letter X. So I'm just going to copy this code here. And then for the title, it's of course an optional, but I actually want to insert what the title will be. So I do \u curly brace and then paste my Unicode. And then I want the superscript. So I'm going to go back and look for the superscript 2. Oh, and there you go, superscript 2. So I'm going to go ahead and copy that. Go back and then do my \curly brace, u curly brace, and then paste my code. And then for state, there's different states for these buttons, but this is going to be just the normal state because it's just going to be a normal button. There's nothing fancy about it. So actually I'm going to comment this out so you can actually see what this looks like when without setting the special looking title. So I'm going to run this. Oopsie. Okay, so you see it does have the X caret 2. It's definitely not what I want. So I'm going to stop this and then uncomment this out and then do build and then run it. Oopsie. Sorry, jumping all over the place. Sorry about that. Okay, so as you see here, my button X superscript 2 appears exactly how I want it. So that's one way you can use Unicode, is if you want something to look a little different than what you had originally wanted before. That's one example that I can give in order to do so. Okay, so that's Unicode. Let's see here. Okay, so I think I covered what I was going to cover for Unicode. And I think I did. Okay, so counting characters. Sometimes you do want to know like a character count. One way to do so is if I look at, let's create another variable here. I'm just going to do German greeting because I can't think of anything else right now. And this is going to be just a typical greeting. Guten Tag. Right. So say if I want to count the characters in this string, how you do so, for whatever reason you might need to, it's actually quite helpful. We can use the count property. So we'll do German greeting, again do our characters, and then dot count, and we'll count the characters for us. So there are 9 characters in this string, which is absolutely true. Okay, so that's character count. Now it comes in handy if for whatever reason you need to know what the characters, the count of the characters. That's definitely useful. Next thing is accessing and modifying a string. So one thing about strings is, yes, they are considered a collection of characters. The characters you can think of kind of as like a collection, like a little bit like an array in a sense. The thing is when you look at the string index, each string value, each character is associated with index type, and the string index corresponds to the position of the character in the string. Now the thing to remember, to keep in mind, is that Swift strings cannot be indexed by an integer value, unlike an array where you try to find the value by the index using an integer. You can't do that with a string. So you have to use start index and end index. So I'm going to actually write that down for you. So we actually use dot end index and dot start index, along with a couple of other things to get access to the beginning and end of the string characters. It also helps you, especially if you need to iterate over each Unicode scalar, which I forgot to mention. The Unicode scalar, what that is basically it's a unique 21-bit number for a character or modifier. So when I was doing the U plus the code, that is the scalar. So the scalar for say front-facing chick. So I'm going to just show you. So say for front-facing chick, the Unicode scalar is the U plus 1F425. So if I actually copied this and let chick equal, I did the Unicode scalar U, the code here, that will be the chick. Okay, so that's what a Unicode scalar is. Okay. Alright, and the reason why, again, that we use end index and start index is because each character, they basically have different memory, like it requires different amounts of memory depending on what code it is. So that's another reason why strings don't use integers for the indexing. Alright, so now we just don't use end index and start index. We want to be able to go through the whole entire string and pick and choose where we want to pull things out of. So these next sets of methods will help us do so. So predecessor, accessor, advance by, and range of string. This will help us modify strings as we see fit. So predecessor method is a method that accesses its value or a value immediately preceding said index. So I'm going to take my German greeting variable up here, and if we do end index, we will get the end, which is 9. which is according to our character count, correct? And if we look at the beginning or the start, we see the start starts at 0. Okay? So that gives us some things we can work with. So if we look at an index for the greeting, we do the end index. So what we're going to do is we're going to look at the end of the index or end of the string, and using predecessor, what we'll do is we'll look at the next, the index preceding the end. So instead of looking at 9, it will look at 8. And that's exactly what it is. And if we wanted to pull the value at that index 8, how we do that is we do our string, our brackets, and then insert where our index is going to be. So we just bring this variable down here. And we see at index 8 we have a G. Okay? So successor is the opposite of predecessor, so it's immediately succeeding or immediately after whatever the index you're starting at. So let's do var successor index, let's do our drawing greeting again, do start. So this is going to start at the beginning of the index. The successor will be the next index over. So it should be 1, and then we do successor, it should pull out the position 1, which is true. See, we have position 0 at the start, successor would be 1, so it's 1 over to the right. And if we want to pull out the value at that index, we'll just do successor index, and it will pull out U, which is correct. U is at the second position. Okay, so advance by. Basically, advance by any index that's in a string. It can be accessed from any other index by chaining methods together using the advance by method. So I'm going to go ahead and create another index. So let advance by index. So I'm going to do again the German greeting one. I'm going to do the start. And then this advance by will allow you to advance by X amount of spaces over. So instead of just doing, successor, which only jumps 1 to the right, or predecessor, which jumps 1 to the left, you can actually do advance by to get to certain spots inside of the string. So let's say I want to advance by, let's see, 1, 2, 3, 4, 5. So the 4th position. So we're going to be at the 4th position, and let's see what's at the 4th position. So we do German greeting, or square brackets, advance by index, and it should be N, which is correct. So that is the 5th position. So you can see we can access certain parts of the string using these methods. Alright, so range of strings. So say if you wanted to get a range, we've only been, going one index at a time, but say I want, the range of the last 3. So we use range of string in order to do so. Actually, wait. Range of string. Actually, what this does is actually, I believe it searches, for a character in that string. Basically, it's kind of like a search. So I do German range of string, and so basically it finds and returns a range of the first occurrence of a given string within a given range of the string subject to given options. So basically, if you're looking for something in a string, I was actually, the reason why I wanted to do this video is because I was actually working with this on my calculator project, as you've seen earlier, where I had to use it to find a decimal point or a period. So yeah, it's really good for searching. I'll just say that. So let's go ahead and do range of string. So I'm actually going to do that. Let's see if it'll find it. And it does, and its range is 6 to the end of the string. If I was just going to search for one thing, so just say T, the first, actually wait, I'm going to do U. So let's find the U, and U, the range of it is from 1 to 2. So the first to the second, yep. So it helps you to find things, which is great. So indices. Indices basically is a property to create a range of all the indices used to access individual characters in a string. So if you don't want to eyeball it like I was doing earlier with my variable here, you can actually use indices property in order to pull that out. So I'm going to do for index in German greeting, do characters, indices. You see here, returns a range of valid index values. And then what I wanted to do is actually I wanted to print out the German greeting, and I wanted to actually print out the index, so the value at said index. And then I'm going to do some fanciness here, where it's actually going to do that and do a terminator. And then also what I want to print out is I actually want to print out the index too, because I want to see what that number is. And as you see here in our console, this, if I can get it to move up, as you see it prints out G at 0, U at 1, T at 2, E at 3, so we can see each index and also what number it, what index number it's at, which is pretty nifty. Alright, so the next thing I'll be covering is inserting and removing. So these methods basically help you insert and remove certain things from your strings. So the insert at index, basically you can insert a character into a string at a specified index. So if you remember, our space, let's see here, we had our space character here. I want to insert that, so I'm actually going to create another, let's create a couple, let's just create a var another greeting, and this is going to be equal to day, and let's see here, what was the other one? Let's just do Abend or so let's do greeting prefix because I can't think of anything right now. Alright, so we have two strings. I'm going to create another string. And what this is going to be is equal to, actually, I'll just do the A greeting prefix. So A greeting prefix, and what I want to do is I want to do the insert at. So let's do insert, and then our new element, which is character, which would be space. And then where I want this to be is at the end. So do a greeting, and then end index. So you see here, it inserted a space after our string. So again, we can use characters. If we hover over space, we see that it is actually character, and we're able to insert it at the end. We can do remove at index. So if I take German greeting, see what it says. So say I didn't want the G at the end, I can actually remove something from an index. So if we do remove at index, it says remove and return element at index I. So we can actually insert or remove an index. So let's do German greeting dot end index, do predecessor. So we're going to move that A or the G. And then if we look at German greeting again, we see that it is missing the G. Actually, if we did successor, see what happens. Oh, we get an error. And a reason why I wanted to do this error is if you go beyond the limit or beyond the index, you get wonderful error messages. So be careful when you're working with these, because the successor after G, at the end of that index, there is nothing. So, you know, if this was start index instead, I could totally do successor because there is actually something at that index. So it would actually take out the U. So again, be careful when you're working with this. All right, insert contents of. So what this does is it inserts the contents of another string at a specified index. So let's go ahead and insert that U back. So if I go German greeting, insert contents of, and then we can enter in some content. So I want to enter the U back in at index. So we do German greeting dot start index, and then successor, because I want to insert it for that. Okay, what did I do wrong? Oh, forgot to do dot characters. Does that work? Yes, it does. So again, remember, when you're working with this, yeah, sometimes you do need to add the character part because that actually was supposed to be a character. Okay. And so now our German greeting should be Guten Tag instead of, like, you know, misspelled. Alright, so another thing you can do is you can remove at, oh actually I already did remove at index. Oh, what I forgot to do was remove at, remove range. Sorry about that. Okay, so I can actually remove things at a specified range. So say I wanted to remove the second part of this phrase. So Guten Tag, I'm going to move the Tag and do Guten Abend. So we can actually do the range for that. So let's go ahead and do German greeting. We do remove range. Do German greeting dot end index, because I want to start at the end. And then what I want to do is I want to backtrack. So instead of going, I'm basically going to start at the end. I want to back up 1, 2, 3 spaces. So do advanced by, do -3. Hopefully that's right. We'll see. If not, then I'll fix it. And then the range, and I want this to be from -3 to the end. So I'm going to do German greeting dot end index. So you see, I totally removed Tag. So I completely removed that word from the end of my greeting. And then what I can do is I can actually insert now. So I can do German greeting, append contents of, and then I can enter my string that I want to append, which is another greeting. And now German greeting is Guten Abend instead of Guten Tag. So as you see, you can definitely do some really cool things with these methods by combining them. So I use advanced by, which I covered up here. I also covered start index 2 up here as well. So you can, it's pretty powerful, even though we're not necessarily using integers to index. We are in a way, but not really. Okay. So comparing strings and characters, I believe I've covered this before, but basically you can compare strings and characters using something we already know, which is our comparison operators with the double equal sign and the bang equal sign, which is not equal to. All right, so let's do var another name equals Bob. And then if we compare name, which is Bob with a space, and we say, is that equal to another name? Actually, this will not be true because it has a space in it. It will be false. But if it did have a space, it would be true. Do that. And we can also do the same thing, but do or not equal to, and that will actually be true. So again, you can definitely use comparison operators, comparing strings and characters. I know I did string, but you can do exactly the same thing with characters. So if I look at my exclamation point up here, let's compare my exclamation point Unicode with my exclamation point up here and see if they're the same. So we do another exclamation point. Is that equal to exclamation point? Let's find out. Okay, well, we don't get the right thing because binary cannot be applied to operands of type string and character. So let's find out who's the offending one. Exclamation point is a string, so if I'm going to change this to character, what it should do is it should be the same. Go back down here and see if this is true. Okay, we got another error because I messed something up. So I'm gonna comment this out. All right, there we go, it equals true. Sorry for all that nonsense of scrolling up and down, but I kind of did want to show you that even though exclamation point Unicode is actually a Unicode character or a Unicode scalar, and this is just an exclamation point I typed in from my computer, my keyboard. They are the same. Okay. Another thing you can do is you can use prefix and suffix equality to check to see if a string has a particular suffix or prefix, and using these will return a Boolean value, so a true or false. So if I did let's say if I our greeting equals, nope, can't do that. Alright, so I'm going to create another variable using these two here. Let's do greeting equals a greetings prefix plus another greeting. I'm actually going to insert a space in here. Okay. The reason why I'm doing this is because I want to do the prefix suffix that I mentioned before. So if I do German greeting has suffix, so has end talk. See what happens. That's false because I believe we changed it to Avent. So do Avent should be true, and we can do the same thing here. So Avent greeting has prefix gut. It should say true because it does, because it's Guten Tag. Alright, so I covered quite a bit in this video, or this series of videos. Well, this video covered strings and characters, initializing multi-string, creating an instance of a string instead of using a string literal, introduced the isEmpty property, working with characters, concatenating strings and characters, touched on appending, so adding things to the end of, an append if you want to add a character to a string. I also introduced Unicode, which is great if you want to use or create characters that aren't necessarily available when on your keyboard, or for international types or really crazy little things like this little crazy little looking chick. Also counting characters in your strings, how to access and modify them, using predecessor, successor, advanced by, and range of string. I also introduced indices, then also inserting or removing portions of your characters using insert, remove at index, insert contents of, and remove range, and then also comparing strings and characters. And also introduced has suffix and has prefix methods. So hopefully you found this interesting. Again, I do apologize. I said I was going to do classes this week, but I thought hitting this was more important because I hadn't covered it, and I was working with it for quite a bit this week on another one of my side projects. Again, if you find this video helpful, please like it. If you like any of my videos and you want to follow, the best way to do that is just to subscribe. So thank you again, and code on, my friends.